In this video, we're going to look at an introduction to functions. In particular, we're going to look at determining whether or not a relation is a function. So, a little bit of vocab. A relation is simply nothing more than a set of ordered pairs. Um, that's really all they are, an x and a y for the most part. But it could be, it doesn't have to be x and y, it could be anything else that has some order to it, like maybe time and temperature or something. So, the domain is the set of all the input values, usually x, of a relation. And the output values, all the usually the y values, that's called the range. So domain is all the x's or the inputs. The range is all the y's or the outputs. And a function is a relation in which each element of the domain has only one element in the range. In other words, it's a bunch of ordered pairs in which each element of the domain, each x value, gets only one y value. And before we get to example one, you can think of a function as a machine. So a machine, typically you give it some input, it has a job to do, and then it gives you output back. So for instance, a vending machine, name the machine, a vending machine, you give it the money and you make the selection, and then it does its job, and then it outputs whatever it is you wanted. Hopefully, it doesn't get stuck in the coils. So a function is nothing more than a machine where you give it some input, it has a job to do, and then it gives you output. So every input you give it is only going to give you back one output, and that's very important for a function. We don't want to give it some input and then sometimes it gives us what we selected in the vending machine, but other times it picks something else completely different that we didn't want. So if we select the bag of chips, and sometimes it gives us the bag of chips, but then other times we push that bag of chip button and it gives us a candy bar, we might not be too happy and we would say it's not functioning properly. So example one, determine whether each relation represents a function. For those that do, state the domain and range. So we have 4 points here, 4 ordered pairs. We have 1, 5, 2, 5, 3, 7, and 4, 8. So we want to know whether or not each x value gets only one y value. So there's a 1 only gets a 5, 2 only gets a 5, 3 only gets a 7, and 4 only gets an 8. So in other words, since all of our x coordinates are different, this one is going to represent a function. If we had something like 1, 5, and 1, 6, that means for an input of 1, sometimes it would give us 5, but other times for an input of 1, it would give us 6. So if instead of 2, 5, we had 1, 6, along with this 1, 5, it would not be a function. All the x coordinates would not be different. So quick way to check. So the domain is all the x coordinates. In this case, we have a 1, a 2, a 3, and a 4. And the range is going to be all the outputs or the y coordinates. In this case, 5, 7, and 8. And since we already repeated one of the 5s, we don't have to list it twice. So it's okay to get the same output for different inputs, but not the other way around. Part B, we have 5, 1, 5, 2, 7, 3, and 8, 4. Sounds like a bunch of heights. So all the x coordinates this time are not different. So here we have a 5, sometimes giving us a 1 in return. Other times this 5 is giving us a 2 in return. So it's like if we buy something out of a machine, a vending machine for $5, it's a pretty expensive product. But if we buy something for $5 and then make a selection, and sometimes it gives us what's in space number 1, and then other times it gives us something different in space number 2, we would not be happy with that. So because all of our x coordinates are not different, this one is not going to be a function. It's a relation, but it's not a function. So visually, to determine whether or not a relation is a function, we have what's known as the vertical line test. And it's pretty much if we draw a vertical line through our graph of our relation, if each vertical line hits the graph at most only one time, then the relation is a function. So as we'll see from a visual perspective, if each x coordinate gets only one y coordinate, then that means that if we were to graph our function or graph our relation, any vertical line we draw is going to hit it at most only once. So it might hit it only once or it might miss it completely. But if we had one vertical line that hit it more than once, it would not be a function. So example 1a, when we plot those 4 points, the 1, 5, 2, 5, 3, 7, and 4, 8, this passes the vertical line test because we can even use these grid lines. Each grid line, each vertical line we draw hits it only once. So, and again, it doesn't have to be a grid line. You can draw these out yourself and verify that each vertical line you draw hits the relation only one time. However, example 1b fails the vertical line test, which does not make it a function because here we had 5, 1 and we also had 5, 2. So drawing this one vertical line, since it hits these 2 points, it fails the vertical line test, which means it is not a function. So example 2, determine whether the graph of each represents a function. In example 2a, we have this line here going down to the right. And every vertical line we draw is only going to hit the line one time. There's no vertical line that's going to hit it twice or more. So because each vertical line that we draw through this graph only hits that blue line once, this one is a function. Part B, we have this frown here, this quadratic expression here. And if we draw vertical lines through our frown, each vertical line is going to hit it only once. So here we have our quadratic expression is a function. So more on that later. Finally, part C, we have this oval, and if we notice the y-axis, it's a vertical line, it hits it twice, once here, another time here, as well as several other vertical lines we can draw that hit this blue oval more than once. So because we have vertical lines that hit the blue oval more than one time, this one is not a function. It fails the vertical line test. All right, so that about does it for this video. Thank you for watching. I'll see you next time.